Hi guys, in this video we will talk about homogeneous differential equations. So what do we mean by a homogeneous differential equation? Do you know what is a homogeneous function? Well, first of all, let's consider some functions in x and y and see what do we mean by homogeneity of a function. So let's consider, say f1 is y squared plus 2xy, f2 is 2x minus 3y, f3 is cos of y by x, and f4 is sin x plus cos y. Now, the concept of homogeneity essentially talks about that in place of x and y, if you put the input as lambda times x and lambda times y, so does lambda come out of the function? Let's check on that. So if we take f1 and if we put instead of x and y, wherever you had x and y, now put lambda x, lambda y. So your function will become lambda y squared plus 2 times lambda x into lambda y. So clearly what's happening is that lambda square y square plus 2 times lambda square xy. So lambda square is something which is common, right? So I can actually take it out. And now what is getting multiplied by lambda square is y squared plus 2xy, which is nothing but your original function. So that's what is happening here. So what is happening is that you are getting, the moment you had put in the input as lambda x and lambda y, what comes out is lambda square times your original function f1 of xy, which means we will say that this function is homogeneous and there's a degree to homogeneity, and the degree to homogeneity is 2 here because lambda to the power 2 has come out. That's what is homogeneous function. I'll make you write that down as well, but let's first check on the other examples that I had given. So let's take f2. f2 in place of x and y, put lambda x, lambda y, you will get lambda times 2x minus 3y, which means that you essentially have lambda times f2 itself. Now let's take the third function, f3 that we had. f3 was cos of y by x. Now instead of y by x, we'll have lambda y upon lambda x, which makes it again cos of y by x, which makes it again cos of y by x, which means it's nothing but f3 itself. There is no change in the function, right? Now, f4 I had given you as sine of x plus cos of y. If I will put sine of lambda x, and for y we will put lambda y, so you'll have sine lambda x plus cos lambda y. Lambda is not coming out at all. This is not coming out, so we can't really talk about homogeneity here, right? So it's not applicable. The concept of homogeneous functions is not applicable here. So a function is homogeneous. Important for you to know. A function is homogeneous in case what happens? If you put lambda x, lambda y as your input, the function turns out to be some lambda times, lambda to the power something times the function itself, original function itself, or in other words, formally, a function is called homogeneous of degree n if for any non-zero constant n, lambda, f of lambda x, lambda y is equal to lambda to the power n fxy. F of lambda x, lambda y is equal to lambda to the power n fxy. This is what is a homogeneous function of degree n. This is what is a homogeneous function of degree n. Now, we are not here to talk about homogeneous functions. We are here to talk about homogeneous differential equations. So what is the concept of homogeneity in differential equations? Let's try to gather that. Now, by this concept of homogeneous functions, what do we know by far? What do we know by far? F1 is homogeneous of degree 2. F2 is homogeneous of, I don't remember, well, let me just check it out again. F2 is homogeneous of degree 1, because you had lambda times. Now F3 was, your cos lambda x or lambda y upon lambda x was nothing but your F3 only, right? Because lambda cancels, which means that it's 1 getting multiplied by F3. It's 1 getting multiplied by F3, and 1 means I can say that it is lambda to the power 0. I can say it's lambda to the power 0. Or I can say that F3 is homogeneous with degree 0. Homogeneous of degree 0. F4, homogeneity concept does not apply. It's not applicable itself. Now let's concentrate on situation like F3. Let's concentrate on the situation like F3. So F3 is homogeneous of degree 0. Now, another thing I would like to comment here is that F1, if you notice, what you can do, if you have a homogeneous function, what you can do, you can take out some power of x or y can actually come out common. So, in other words, if it was F1 was basically y square plus 2yx. So F1, I can probably write it down again. F1 was y square plus 2xy, right? If I take x square common, the highest power of x that I can take common here, which is suitable, is, let's say, x square. If I take x square common here, I'm going to get an expression which is in terms of y by x. What are you getting? You're getting y by x whole square, and you're getting 2 times y by x, right? So it becomes like a function in terms of y by x. So you can take x square common and you have a function in terms of y by x. Similarly, if you would have taken a y square common, then you would have got some expression in x by y. So I can say that y square, if y, your F1, and since, there's a, key factor of homogeneity here, basically. That's why, you're able to take out common like this. So x square common, then you are getting purely a function in terms of y by x. If you take y square common, you're getting purely a function in terms of x by y. Similarly, you can check it out with the other examples also. Even in F2, the degree of homogeneity was 1. So if you take just x to the power 1 common, you will get a function in terms of y by x. If you take y to the power 1 common, you will get a function which is just in terms of x by y. Similarly, in F3, if you don't have to take anything common actually, because you actually have a function in terms of y by x itself. So in other words, you can say that if you take x to the power 0 common, you have a function in terms of y by x. If you take y to the power 0 common, you have a function in terms of x by y. So we can say that if a function is homogeneous, of degree n, then you can either take x to the power n common or y to the power n common, okay, and convert it to a function, it will look in terms of a function of y by x or x by y, respectively. So we can say that fxy is a homogeneous function of degree n if fxy can be written as x to the power n g of y by x, or y to the power n, a function of, I should be writing not just a function of, say, h of x by y. Now, when is a differential equation called homogeneous? This is something that we will learn now. So a differential equation of the form dy by dx equals to fxy. So suppose you have a differential equation which is dy by dx equals to fxy. So we're just talking about the degree 1. The degree 1 the degree 1 differential equation, order and degree 1. So it's said to be homogeneous in case this fxy is a homogeneous function of degree 0, the kind of function that f3 was. So we say that a differential equation dy by dx equals to fxy is homogeneous in case this fxy that you see here is homogeneous function of degree 0. So in other words, what's going to happen is that I'll be able to write fxy as g of y by x or g of x by y. So this means that homogeneous differential equation would be of the form dy by dx equals to fxy, which could be just equal to g of y by x. And now how to solve it, how to work around it. So we use substitution in this kind of scenario. So if you have a function g of y by x, so I'm going to substitute y by x as some say v, and which would mean that y is equal to v into x, y equals to v into x. Now, since it's a differential equation, we'll be talking about derivatives, so let's just differentiate it once. So that means dy by dx will be equal to, you'll have to use the product rule out here, so it's going to be v plus x into dv by dx. So differentiate with respect to x on both the sides. What are you differentiating? Since you've taken y by x equals to v, that means y is equal to v into x. So differentiate both the sides by x with respect to x. And what do you get? You get that dy by dx is equal to v plus x dv by dx. Now you'll make this substitution. So this means that instead of what you had earlier, now your dy by dx is v plus x into dv by dx. And your right-hand side is g y by x, where y by x is taken as v. So it's gv, it's a function of v. Or in other words, this would imply to that if I take just x dv by dx and take v that side, so it's going to be gv minus v. Of course, it'll be better explained with examples. So I will jump onto examples. Don't worry on that. But right now, just telling you the concept, what's happening here. So this means that what's going to happen is you have x dv by dx equal to gv minus v. Can you see that we have sort of two variables here and we can separate out? So yes, we'll have something just in terms of v and something just in terms of x. So let's just separate it out. So this means that I have a situation where I have dv upon gv minus v, and that's equal to dx upon x, or we can talk about the integrals, integrating on both the sides. We've already done separable variable case. So integrating on both the sides, this is what you will get. This is what you will get. So what have we done? Since it's a homogeneous differential equation, your function fxy is just g of y by x or h of x by y. Just make a substitution, y by x, take it as some other variable, or x by y as some other variable, whatever is suited in whichever case, go by that. And then you'll be able to use your separable variable case. So that's what we've done here. And finally, you can replace v again by y by x to get your final answer. I'm going to give you one example out here. That was a general case. Now let me take x minus y dy by dx equals to x plus 2y. Clearly, if you notice here, dy by dx is a function of x and y. So I can write dy by dx as f of x comma y. Is this a homogeneous function? That's something that you need to answer first of all. So think about it. If you will put lambda x, lambda y as your input, does some power of lambda come out? Well, lambdas cancel out. That means I can say that it's equal to lambda to the power 0 fxy, which means it's homogeneous of degree 0, which means it's a homogeneous differential equation. This is what is a homogeneous differential equation. Now the question arrives how to solve this differential equation. So what kind of y's will solve this? What kind of functions will solve this differential equation? That's what you want to figure out. For this, clearly what we can do, we can either have a form in terms of x by y or y by x. So going by y by x, since I think we've done y by x right now. So that you understand better, so what we can do, we can put y by x equal to v, or y is equal to v multiplied by x. Hence, dy by dx will be equal to v plus x times dv by dx. And substituting on what we have here. Substituting here, so your dy by dx will become v plus x into dv by dx. And your right-hand side clearly is 1 plus 2v, because we basically be writing it all in terms of y by x. So 1 plus 2v upon 1 minus v. So for this, you will have to take everything in terms of v to one side. So what we have is, we will separate v terms and x terms. So we will get x dv by dx is equal to, you will subtract v from your right hand side. So you will get 1 plus 2v minus v plus v square upon 1 minus v. So that gives you 1 plus v square upon 1 minus v. Or in other words, now let's collect our terms. In terms of v, we have 1 minus v upon 1 plus v square dv equals to dx by x. Integrating on both the sides. Or what we can also do is, what I have done here is, because I wanted, I will have to do some more substitution here, right? So I will have to do some more substitution since I have 1 plus v square. If I substitute that as t, so I will get 2v plus 1 as 2v plus 1 dv as dt. So I would want v instead of I have v here. So I v minus 1 here. I have 1 minus v here. So let me just write it. I wrote it in terms of v minus 1. So that next what I can do is just multiply and divide by 2. You can have a different way also of making the substitution. Definitely the substitution I want to make is this. This is the substitution I want to make. So how it could be useful, you have to see what is the best to be done. So what I've done is I've taken minus sign common so that it becomes v minus 1, and here you have minus dx by x. Here then, since I require 2v plus 1, so I require 2v. So I've multiplied and divided by 2. So I'll have in the denominator, I have 2, and in the numerator, I'll have 2 times v minus 2. Then since I require 2v plus 1, so I'm going to add and subtract 1. So adding 1 will give me an easy substitution, and then you will have minus 3 out here. You could have seen that directly also, but I just wanted to explain it thoroughly. That is why I've taken so many steps here. And then I've separated it. So I have 1 by 2 times integral of 2v plus 1 upon 1 plus v square dv minus 3 by 2. So since you will get minus 3 from here, and you have a half outside. So 3 by 2 here, integral 1 plus 1 upon 1 plus v square dv equals to minus of dx by x integral. So now I will first just concentrate on this term. So clearly you just substitute, and here you will have dt by t Okay, these are unbounded integrals, so bounds need not be taken care of. So dt by t, so that will give you just log t, right? But this term is not that simple. This term is not that simple since you have 1 plus v square. So I've created x square plus a square scenario in the denominator. So what I've tried doing here is what you will have to also do. You probably need to know some amount of integration for this. Otherwise, I'm just letting you know that we are trying to make it to a scenario of 1 upon x square plus a square, which could be translated in terms of tan inverse. Okay, so this could be translated in terms of tan inverse. So what I've done is I've tried creating, since you have v square plus v, so that means you can make a whole square with half, right? Because 2ab is giving you v. So you already have v square, so you will require 2a has, that thing has to be half, right? So half square. So half square added and subtracted, and that's giving you v plus half whole square, plus basically it's giving you 3 by 4, or you can say root 3 by 2 whole square. It's giving you root 3 by 2 whole square. I've by mistake written dv twice. I've already written that in the numerator. Now I'll just concentrate on this term. I'll just concentrate on this term now. So here you can take this thing common and make another substitution to make it look like 1 plus, see the derivative of tan inverse x is 1 upon 1 plus x square, right? So that is why the integral of 1 upon 1 plus x square is tan inverse x, right? Is tan inverse x. And that's the reason, that's how, you'll have to probably make another substitution and get to tan inverse x in this integral. And within that substitution, 3 by 2 is already outside, and 2 by root 3, or from the denominator, basically 3 by 2 or 2 by root 3 will come out after cancellation and all. You'll be substituting this as t. So again, t or u you can take. So dv will be some du. So you'll have one time just to root 3 by 2 out here. So which will give you this cancels, and you will get root 3 here. And this will turn into tan inverse of the whole square is basically 2 times v plus half whole square upon root 3 whole square, right? So 2 by 3 v plus half. That is what is your x. You have to realize what your this thing will be, because tan inverse of that will come out. And that's equal to minus of. If you notice, you always had minus of, this thing also comes here, and it was minus of log mod x. So log mod x can come here. And this is what is finally, in terms of v, your function which satisfies this differential equation. Well, of course, you can now convert that in terms of just x and y as well and solve it. So write down in terms of x and y. So v is equal to y by x. Just substitute it. What I've done before that is I have, since you have half log x here, so you can take it as x square and then combine with, because it's log, you can combine log. So log a plus log b is basically the product, log of the product ab, right? And then after that, in the end, you can just substitute y equals to y by x equals to v, and that will give you finally the answer. Finally, the answer that you will get is perhaps this is what I got. And I guess you shall also get the same answer.